95% confidence intervals are really important values that actually tell us quite a bit about our results. So, just at a very high level, you can think about 95% confidence intervals as a range of values that we are 95% sure or certain that contain the true population parameter. Remember, we are trying to estimate the true population parameter, and it's definitely not feasible most of the time for us to actually survey everybody in the entire population. So we take a sample of people and we collect information on a given sample. Now remember, whatever value that we get from that sample is never going to be exactly what the parent population parameter value is. So for example, if I am trying to estimate the average GPA of students at Cal Poly and I take a sample of students, let's say I sample 100 of them, the GPA that I calculate for that group is probably going to be slightly off or different from the actual GPA of everybody at Cal Poly. So when I take a sample, I can calculate a point estimate that is basically my best guess of what that, I'm using that to estimate whatever that population parameter is. Now, when we're thinking about epidemiological studies, we are typically examining the relationship between some independent variable and some dependent variable. And when I do that, I'm typically calculating something like an odds ratio or a relative risk. I'm trying to quantify the relationship between those two variables. And to do that, I typically collect data and then I calculate those things. For example, a relative risk or an odds ratio. A relative risk and an odds ratio are essentially just fractions. And so they're comparing a value in one group to another group. So for example, a relative risk is just a fraction of the incidence of disease in the exposed group compared to the incidence of disease in the unexposed group. So if those incidence rates are the same across the exposed and unexposed groups, I would expect to get the null value of 1, meaning that there's no difference across those groups. It's the same idea for an odds ratio. If I get an odds ratio of 1, what I'm saying is that the odds of exposure is exactly the same in cases compared to the odds of exposure in controls. So at the end of the day, when you're thinking about an odds ratio or a relative risk, which is what we're going to focus quite a bit on in this class, the null value for those measures would be 1, indicating there's no difference between those groups. So when you have 95% confidence intervals, we can calculate whatever that relative risk or that odds ratio is, and we also get confidence intervals that tell us our certainty in which we think the true population parameter falls. Your point estimate that you calculate, your relative risk or your odds ratio, is always going to fall in between that confidence interval range. It will never fall outside of that. The idea is that confidence intervals are arranged around your point estimate, around your odds ratio, or around your relative risk. You might be wondering at this point, so how do we determine, using confidence intervals, whether our results are statistically significant? And in this slide, I'm going to show you how to do that. When you're looking at your confidence interval, if you get a confidence interval that, let's say, falls on the lower end is 0.5 and on the upper end is 1.5. You can see my confidence interval is displayed here by these bars with those values underneath. If this is my confidence interval range, ranging from 0.5 to 1.5, that range includes the null value. I am 95% sure that the true population parameter falls somewhere between 0.5 and 1.5. Let's say, for example, I am using a relative risk and I calculated a relative risk, which I have not shown on this slide. It would fall somewhere between that 0.5 and that 1.5. But the big key takeaway here in terms of statistical significance is that if I have a relative risk of 1, that means that there's no difference between my comparison groups. There's no difference in the incidence between the exposed group and the unexposed group. Therefore, there's no association. And if I am 95% sure that the true population parameter falls somewhere between this 0.5 and this 1.5, and 1 is in there, it's possible that the true population parameter is 1. So if my 95% confidence interval, when I'm working with something like an odds ratio or a relative risk, if that 95% confidence interval includes 1, I would say that my results are not statistically significant, and I would conclude that there is not an association between my variables of interest. I can't rule out chance. However, let's say that your confidence interval falls over here. And in these green lines, I am, in this example, saying that the lower end of my confidence interval is 2.5 and the higher end of my confidence interval is 5. I haven't shown my relative risk here, but it would fall somewhere in between that 2.5 and that 5. What I'm saying here is that I am 95% sure that the true population parameter falls somewhere in between 2.5 and 5. This range of values does not include 1, which is the null hypothesis. Because that range of values, that 95% confidence interval, does not include 1, I would conclude that my results are statistically significant. I am 95% sure that based on this range of values, I'm 95% sure that 1 is not included as the true population parameter. Therefore, based on these results, I would conclude that my results are statistically significant. There is an association between my independent and my dependent variable, and then I would go on to use my point estimate to interpret that association. In summary, if your 95% confidence interval includes 1 when you're working with something like a relative risk or an odds ratio, those are results that are not statistically significant. However, if your 95% confidence interval does not include 1, then I would conclude that my results are statistically significant and there is a relationship between that independent and that dependent variable.